Hey guys, this is Mr. Sal. We're going to look at solving systems of equations by substitution method. Thanks for watching. Don't forget to like, subscribe, and comment about the lesson below. Solving systems by substitution. So we're not looking at a graph anymore, right? This is a process which, I don't know, I think it's kind of nerdy, but it still works. Manipulate an equation so that one variable is on its own side of the equal sign. Doesn't matter if it's x or y, by the way. Determine what one of the variables equals as an expression. I guess that's kind of what we did there. And then 3, replace that variable in the other expression with the expression. You only have one variable now, so solve for the unknown, which is a lot of steps sometimes. And then replace the known value that you just solved for in the other equation for the final unknown. So you go back to the original with 2 variables, replace one of them, and solve for the one you don't have yet. And then finally, check your answer in both. Again, just like we did with the graphing, check it in both equations, all right? This whole process really becomes like checking your work anyways. It's just checking your work with an expression instead of one single value, right? Like when we checked an ordered pair in an equation, we replaced an x value with a number, and then the y value with a number to see if it was true. This time, though, we're replacing an x or y value with an expression, which sometimes can be big, sometimes it's small. But then it becomes more of just solving an equation problem, which, if you guys feel comfortable with, you'll do very well with this one. 2 ways to do this. And the first way is, I guess, to kind of follow the instructions on that last part, is to isolate one of the variables in one of the equations. Now I'm looking at that second equation. That looks very nice. And I know I can solve for that y value very quickly just by dividing both sides by 2. So I know then that y is 2. Now this isn't an expression, okay? Although in the future it most likely will be. But this gives me not only a value to replace into y in the other expression, and then I can solve for x. But also, it gave me the actual value of y in the ordered pair. Now, you may be wondering, why the crap is this an ordered pair? It's because it's a graph, guys, just like on that first part. That's why we graphed to begin with, so we can see the actual answer to these. I guess I'm a little antsy for fall break, too. My bad. We'll try not to make it like the other day, though. 4. That's better. Thank you. Now, if I would have checked my work, and we would have found that eventually, but finding it now is even better. So, I have 4 in that ordered pair, right? Now, again, that's a 4 in an ordered pair because that's the point where the 2 lines will intersect. So let's go to the other equation. And now, since I know the y value, I can replace it in that expression there with 4. And we're going to solve this for x. And x equals 11. Now, this is going to give us a true statement for that top equation. 3 times 11 plus 2 times 8 is 41. I mean, we just solved for that, so it should just confirm that. But if I replace x in that second equation, it should still be a true statement because y is 4. Now that may seem weird that I just said that. There's no x to replace in it, right? So it should be really easy, actually. There's our answer. All right, I don't know. To me, this one's almost too easy. They told us what x was. Even though it does have a fraction with the y, right? What I mean by that is I don't have to manipulate that bottom equation. It's different. It's not giving me the value of x directly, just like the last example. But what it does mean is that in the equation, the top one, negative 8x, I can replace the x value. Now this one's nice because it is an expression here. I can replace x with negative 1/4 times y because the 2 are the same. So whether I show it as an x or a negative 1/4 y, it doesn't matter. This is going to be negative 1/4 y The reason why I have that as a negative 1/4 y is because now I have one equation with one variable, and we've seen that before, so we should feel pretty comfortable with that. In other words, if we just had started with this equation right here, at this point in this class, I would expect you guys to be able to solve that. So again, we should feel a little bit more comfortable with these. Let's go ahead and solve this equation. So that's a 1y right there. So combining these two is 3y. Y equals negative 2/3. So this gives us an actual numeric value for y, which is good, because I got two equations to choose from here, okay? We have negative 8x plus y equals 2, and we could solve for x that way. But I really like the second one, because if I replace the y value in that equation right there, I'm going to get the x value directly. There's no need to manipulate either side for any of the variables or to isolate anything. It's already isolated. So I'm going to replace the y with the y value we found at 2/3, and that is multiplied. So 1 times 2, that's fraction multiplication. You guys got calculators that'll do that. 4 times 3 is 12. We'll simplify it. X equals negative 1/6. Now this is, again, an ordered pair on a graph where the x value is negative 1/6 and the y value is 2/3. Now we do have fractions, which, and this seems a little weird to me to have it this early, but let's look. So negative 8 times negative 1/6 is negative 4/3 plus y, which is 2/3. So that's 4/3 plus 2/3, which is 6/3, which is 2, and that checks off. We don't need to check the second one, because we already know that negative 1/4 times 2/3 is negative 1/6. Well, let me take that back. We just did kind of check it, so we're good. This is a nice setup. We got one equation in standard form, and then the bottom equation there is in slope-intercept form, which is good, because slope-intercept form gives us the y value, and we know then that y equals 2x minus 2, right? So in the standard form equation, 2x plus y equals 8, and yes, I did separate that on purpose with space, because the y value, maybe I should have written that in red, it equals 2x minus 2. Now I'm going to put this in parentheses just out of habit, because if that was a minus y, we'd have to distribute that subtraction as a negative 1. Now this is addition, so it's not going to make any difference. So I can get rid of them. But just know, if it were subtraction, we would want to keep the y value there in parentheses. So this is what I meant by we can replace variables with kind of full expressions on this. And at this point, it's just an equation where we're solving for, in this case, x. So I'm going to combine my like terms. 2x's with 2 more x's is 4x's. Then I'm going to add 2 to both sides. Then we'll divide both sides by 4. So x equals, I'm going to simplify that to 5/2. If you want to, if you want to show the decimal on that, that's fine. 2.5, but I like the improper fraction on this thing. Now whether you do this now or later doesn't really matter, but this is, again, an ordered pair where the x value is 5/2. So we got a couple options on this thing. We got that top equation or the bottom one, and we can solve for y. Now, I know which one I would pick, but it doesn't matter because you guys may pick a different one. So which one do you want me to choose to solve for the y value? Slope-intercept form. That's the one I would choose because it will give us the y value directly. And like before, we're going to replace the x with the x value we know we have now, or we think it is, 5/2. And we'll solve this for y. So on this one, y is 3. And that works in the slope-intercept form 1. 3 does equal 2 times 5/2 minus 2. That's true. But what about the top one? 2 times 5 halves is 5, plus 3 is 8. So the top one checks off as well. And we can circle our answer with confidence. So we're still solving by substitution. And there's a couple ways we can do this. So again, we can isolate a variable or solve one of the equations for one of the variables, and we could choose. To me, and it's whether it's easy or not doesn't really matter, but I would look at that top one, and I know to get just the x equals, I just need to divide all the terms by 2. Let's look at that. And like I said, we're going to divide all the terms by 2, which gives me x equals 3y minus 8, which is kind of like an inverted slope-intercept form on that, okay? Not that that matters right now. But this gives me an x value to replace in the other equation for x right there, right? And I'm going to replace the x with that value we have, the expression. And this one does need to be in parentheses because it was negative, 3y minus 8. Now that negative means we're going to take the opposites of them, so if you wanted to skip that part, just be very careful. Again, I can treat that as a negative 1, which I'm going to distribute into the parentheses. And we do have this equation, which we're solving for y. So the order would be to distribute, simplify by combining like terms, isolate your variable, divide by the coefficient, and you got it. Okay, so let's look at that. And so that's the distribution, combine like terms. Negative 3y's plus 3y's is actually 0y's, plus the 8 equals 8. And 0 times y is 0, which means I can change that to phantom 0. And I have 8 equals 8. Now this is kind of funky just because it's been a few weeks since we've seen anything like this. What the crap does this mean? So this brings up several other questions. Does 8 equal 8? At least that's true, right? Okay. Now you may, that's not a sarcastic question because we're going to see problems where it's not equal. Well, then what do we do, right? 8 does equal 8. Does it always equal 8? It does. Okay, so what this means, just like it did before when we got something like this, is we could reduce this to 0 equals 0. Does that look more familiar? No, because it was so long ago, right? What this means is that these two equations are the same. It means if I graphed them, one would look something like that, and the other one would look something like that. It just changed colors, right? So, this one has infinite answers. Why? Because 8 will always equal 8. Always. An infinite number of times, infinite solutions. Now you may be wondering how the crap that happened. Well, we could manipulate those equations into slope-intercept form and find that they would have it would be the same equation if we did that, okay? But of course, if just by using substitution, we see that we have those two values which are equal. So, like I said before, though, there's some valid questions there, even though they seem kind of sarcastic. If we got something like 6 equals 8, is that true? No, 6 is not equal 8. So what would the answer be then? Does not exist. So the two lines would be parallel in that case. The equations would manipulate to be something that looks the same, but the y-intercepts would be different. All right, another generous one where they've given us the x value directly. So I'm going to replace the x value in this equation with this business right here. And yeah, we'll replace that x with the 10 minus y stuff. And from here, it's just solving the equation for y. All right, so in the ordered pair, we have the y value at a positive 2. And we could go back to the original, or the top equation there. let's say that we didn't, we didn't notice that second one would make it really easy, and we just wanted to do it on the first one. I'm not doing it to be a jerk, all right? I just want to show you that it still works, okay? So 2x plus y equals 18. And we know the y value is 2. And we'll just solve for the x value on this thing. And we get x equals 8. All right, well, let's test this thing then in the second equation. So, well, I'm sorry, let's do the first one. 2 times 8 plus 2 is 18. And then the second one, equation x equals 10 minus y. 8 does equal 10 minus 2. So that is true. So yeah, I mean, again, you may have preferred to use that second equation to solve for the x, and it would have been a little bit faster. But in any case, it doesn't matter, okay? And you get to choose. All right. Again, they've given us y value to replace directly. Right? We got this y is 4x plus 6. So in this other equation, maybe that's too much space. But in any case, we're replacing the y with 4x plus 6. This is a great example because that's a negative 6 that we got to distribute into this to solve for x. Be careful because a lot of times we see that on tests where it's forgotten that the 6 is going to take that operation to its left as its sign. So when we distribute this, there's going to be negative 24x, and then this would be negative 36 right here. And then we just solve for the x's as usual. Because now we'll just divide both sides by negative 22, and we get x equals 1, which again is part of that ordered pair. Positive 1 right there. Okay. Well, unlike before, we'll just do the slope-intercept form with this one because we have the x value. So, and we'll replace the x value with the 1 that we think the x is. And just solving this for y, 4 times 1 is 4 plus 6 is 10. And that's our y value. So it checks off for that bottom one, but what about the top one? 2 times 1 is 2, minus 6 times 10, 2 minus 60 does equal negative 58, and it checks off. Very nice. Well, we got fractions on this. However, the nice thing about it is it's y equals, and then the other one is y equals. So which y do you guys want to replace, the top one or the bottom one? Top one? It doesn't matter, right? So I'm just going to do the top one because it's convenient. I'll still write it out, okay? But we can see from the second equation what y does equal, even though it says in the top one as well. Negative 8/3 x plus 101. Well, now we got x's on both sides of the equal sign, so we've got to choose which side we want the x's on, or I guess it doesn't matter what the order is. We could find common denominators for all the terms and then just get rid of the fractions. But I'm tempted to work with just the fractions as they are on this one. So which side do you guys want the x's on? Because it doesn't matter. I would have put them on the left as well, which means that that 101 is in the wrong position. We need to subtract it from both sides. But also that the negative 9/4 x is on the wrong side as well, so we'll have to add it to both sides. Again, the reason we're adding it, didn't give myself a lot of space there. The reason we're adding it is because it's going to zero that out. All right. Well, the 86 minus 101 isn't too bad. But the fraction on this, I don't know, could be a little worse. But I've got 9/4. We need common denominators on that, so we'll combine those two. And 12ths of x's, negative 5 of them. And this equals negative 15. Now I'm going to do this in 2 steps, even though some of you guys know you could do this in 1. That's okay. I'm going to multiply both sides by 12 first. By 12. So that cancels those out. That essentially gives us common denominators. So negative 5x equals, then we'll divide both sides by negative 5. which gives us x equals 36. And yeah, we can put that in the ordered pair right now. X is 36. Now that I have an x value, I have two choices to solve for y pretty directly. And you guys get to choose which one you want. So we have a value for x on this thing now, though. So we'll place that in there. And we'll solve for y now. So y equals 5. And we just, we got that from the top one. So we should check with the bottom one. Negative 8/3 times 36 is negative 96. Plus 101 is 5. So that one checks off as well. And we know our answer is good. So I'm going to substitute that top equation into the bottom one, right? So 12x minus 4. But y now is this 3x minus 11 business. And this equals negative 46. So distributing the negative 4, negative 12x plus 44. And we got 12x minus that 12x plus 44 equals negative 46. But yeah, when we combine these two, we get 0 x's. But the problem is, we don't really need to show 0 x's because make it a phantom 0, which means we also don't need to show that that 44 is positive because it just is. And then we got 44 equals negative 46. Now they're close, even though they're not, just in opposites, right? But 44 does not equal negative 46 ever. It never will. So, yeah, it does not exist. Now, again, what this means is that if we were to graph these, on this one, I would have a line, I don't know, something like this one, and then maybe another one. I didn't do the math, but something like this, okay? They're parallel. They'll never touch. So there is no intersection, no solution. The intersection does not exist. Let's do this one. Just so you understand, though, this one, we're going to use substitution. But next time, in 4.3, we're going to use a different method, which you may or may not like. We'll give you guys some options, though. I do believe on the test, however, that they ask for specific methods, which you have to show how, or to use. You have to use it on the test, okay? So just be aware of that. Even though both methods work, you have to use one or the other. So since it tells us to use substitution, we need to replace or manipulate one of the equations for either x or y. And since neither of these look convenient, you get to choose. That's very good. So the top one, are we manipulating for x or y? What do you guys? Y, okay. Which is good, because it's really just manipulating this into slope-intercept form, right? Which is great, because then we get to see the slope and y-intercept. So on this one, I would subtract 4x from both sides. Now, since this is not, we don't have to use formal slope-intercept form, I'm just going to keep it like this. Divide all the terms by negative 8. Now, if for some reason, you know, because we get so used to seeing slope-intercept form, we want to switch this around. You can if you want. But just because it's awkward, I'm going to keep it the way it is. Now, we use the top equation to manipulate for y. Just be careful, because since I use the top one to manipulate it, I've got to replace it into the bottom one. If I replace it into itself, it's going to look like there's infinite solutions. All you did is you just put one equation into the same equation, which doesn't help us, okay? So I've solved for y, and I'm going to use that bottom equation now, because we solved for y in the top equation. Okay, well, we'll solve this equation for x, which will give us the value of x. And then finally, we'll divide both sides by 5. And yeah, that gives us x equals 14/5, which is okay to have a fraction as part of the answer. So in the answer, the ordered pair, we got an x value of 14/5. Now all we need to do is solve for y, and we're going to use the original, one of the two original equations, and it doesn't matter which one we choose now. Which one do you guys want to choose? And at this point, we're just solving for y, which, no easy fractions on this one, but that's okay. So I'm just making common denominators right there so I can subtract. I mean, if you guys got calculators in, it's a lot easier, but whatever. Well, we will divide both sides by 4 then. And again, your calculator can do this part for you, but I don't know, whatever. Y equals 47/5. That's what I got. So that's my y value at 47/5. I would definitely recommend using a calculator to check this. But when I did it, it worked.